Well, it's not often we get something like this in the box. Very nice. Well, his table's tidier than mine. So, we've got a Euro 3100 UK, and it might look immaculate in a box, but he tells me that the previous owner has managed to break every coil in it. So there may be no possibility. We're so behind with the organ that, because we've had so many repairs in, I kind of felt obliged to do more than I should do, even though we've said it's one per week. And so this is strictly going to get 40 minutes spent on it. And if it's 40 minutes today and 40 minutes tomorrow and 40 minutes in 10 days time, well, that's how things are going to be. So I'll put that on one side. I did have a box to one of our own Euro 3100s and inadvertently burnt it. I also burnt the mic and the instruction book. Right, so first of all, we're greeted with a little bit so we're talking about one of these. And it's the fairy light version, because I was doing the metered version of it back. Right, put the other glasses on, switch on the smouldering bat, which is a bit like a soldering iron. So let's just see if any of these are going to move. That's going to move. That's going to move. The ones with wax on don't look to have been broken. That's going to move. So we've got these 1, 2, 3, 4, 5 in the receiver. That's okay. That's okay. That's broken. That's broken. We might be able to get it out. So what I'm able to do here is to turn it around and put it in the other way. So we're now at 2, which is scary. So what we've got to do with those, we've actually got to unsolder those 2 coils. So that's better than being like 7 broken ones. At least there's only 2 broken ones. And I may as well do that now before we actually launch into it at all. The other thing I will be doing is I will be changing the capacitors in the power supply. If this can be run off 12 volts, no it can't. I was going to say then we would run it on 12 volts. We'll see how that performs, but I will be changing those capacitors automatically. So I'll take the bottom lid off. I think once you take the bottom lid off, the whole thing falls apart, if I remember with these. So normally we'd launch into the repair by testing the radio and writing down how it performs, but we know that it's damaged. So it's a matter of trying to get it back working and then realigning it. Oh my goodness, what's happened to it underneath? It is a disaster area. What's all this? Well, somebody didn't buy any isopropyl alcohol for Christmas there. Right, I might get Mr. Chippy to take these out. I will get Mr. Chippy to take these out. What I'm going to do first, I'll tell you what, I'll get him to change the power supply capacitors. Mr. Chippy's about to get a desoldering job. Yeah. He's actually going to go and shave his beard to some degree. And one of the reasons we've kind of accelerated our throughput of radios, instead of just leaving them whilst we've really got time to do them, is for this customer, because he's really keen to get this back. And I must say, it's only been with us about 10 days. I think he got visions of it being here 4 months. But while we're on this organ job, you know, that has to take priority, and it's a actually, we worked out, 17,500 hour job, so it's a lot of time, and so something has to give, and it's these that have to give. So we've got a really dry joint there. So I'll have a word with him about those dry joints just there, and I'll get him to do those power supply capacitors. I think we'll leave it at that, and we'll see what we can do once we've got those two coils out. Because what the idea is, we want to get those out and remove the cores from the other side. That should be possible. Most cores you can. I just hope that that is the case, because we've no spares, and you know, if I can't do that, then the radio is scrap. Right, so we'll pause it at that point, and we'll see what Mr. Mega Chippy. I'll just put red highlighter on those so he can see which ones they are, just in case he can't see what ones they are. Now, we said that one's alright. And that one's alright. Right, we'll leave it at that. Right, so what have we done? Well, what's Mr. Chippy done? So what we've done, if you remember, we got it down to 2 coils that were broken. Mr. Chippy unsoldered the back one and that next one. I haven't got the L numbers unless I have in the folder. No, it doesn't look like I've got that handy. Anyway, So what's happened is, once Mr. Chippy removed that back one, I got it on this bench and I was very carefully able to twist out the coil, the core. So that's looks, and I've put a recovered coil core from a scrap, I think it was a great chassis set. And then this one, we've borrowed this out of my own set because I can't yet get the core out. So the only kind of one we're not sure about is that, and he's checked it for continuity and it looks to be okay. And so we've done it like this. We've borrowed that so that we can see whether we can get this set to work. Then we'll recover that and we'll have to do something about his coil, because I'm not ruining my set to sell him a coil for a couple of quid. So we're not doing that. Don't play that game. But we're going to borrow that temporarily just to see whether we can get the set to work. Mr. Chippy found some print faults underneath and he's dealt with those. So that's a step in the right direction. So he's done the power supply, capacitors. So instead of us going through this in the normal way, we're going straight for the jugular and we're going to see whether we can get this thing to receive. So I've got, I'll put the cyanide meter on the inset screen. We'll get 2779125 on the signal generator. It's Monday, it's supposed to be the hottest day ever. I left 4 air conditioners on overnight. I hope we don't have a power outage. Right, so here goes. I'll plug the mic in so we've got receive continuity. It's an immaculate set, this, and it's a shame it's come to this state. Starts off on channel 9, annoyingly. So I've got absolutely nothing on receive. Hang on, I haven't plugged the aerial in. Yeah, we'll just change all the transistors. Tell you what, we have got receive. Now that signal generator is on full pelt. So I'm just going to do a quick. I don't need to. I was going to see whether we're actually somewhere on frequency, but I won't do that. We'll worry about it being on frequency later. We'll just get this receiver rough tuned up. I think he said in his letter that it was absolutely, you know, you would just hear if you had a 4-watt radio a foot away type of thing. So where are we with the attenuator? We're at full pelt. So let's drop that down. See whether we can get S9. So that's S9. I'll have to plug the cyanide meter into the extension speaker socket, and then we'll see where we are. So at the moment we are at 25 microvolts. Let's turn the volume down a bit for 12 dB cyanide. I'll just get a scrap piece of paper. Oh, RS's bill. Dear customer, we want some money out of you, or else. So it's team Euro 3100 UK. Now I can't remember which coil's which, and I really ought to be looking at the circuit diagram and working it out. So I've only done this a few weeks ago, haven't I, with my own set, so goodness knows where all the paperwork went for it. What we're going to do, we'll just concentrate on what we've dealt with the set. So let's get that down to 4 dB. So we're now looking at 10 microvolts. So I've got this core hanging out because it's the one I've just put in. Wow. So we're now listening to 3 microvolts. So the set's working. So there we are, there's our peak. So we're at 1 microvolt. So now we'll do some of these other coils which we know are in the vicinity. I wonder how much my coil needs touching up. That was absolutely spot on in the right place, even if it's come out of another set. I expect that's detective. No, it probably isn't, but we'll just go through that. Put the biggest signal on for that one. So let's see what we've got from that quick tune-up. We've got 0.85 microvolts. So we'll now start servicing the set in a normal way, because we know if we don't get any better receive out of this, it's absolutely fine. That's absolutely usable, no problem at all. So what we've now got to do is, I'll just fetch the coil. So I've taken the can off this to try and get it out, and what I'm going to do is we're going to clamp that in the organ workshop into a cast iron vise, and we're going to use a diamond drill, 1mm. The idea is there's going to be no possible lateral movement to try and destroy what's left of the core in there, so we can actually break it out. It's right down at the bottom and it's beyond the threads, and you can't get it from underneath because there's a capacitor in the way underneath. So it all depends on whether we can do that. So I'm not wrecking my radio just to sort out this repair. So it does rely on that. There may be an alternative coil we could kind of jerry rig in there on stalks, but I want it to be original. So at least the radio with my coil is working, and all the other coils which were stuck, there's the two. The one we've had to take out, and the other one we have managed to get working. So that's a real step forward. So we'll look at the power supply to see whether it's doing something like 13.8 volts, or if it is indeed adjustable. So it's not an adjustable power supply, that's fine, but as long as we know, see what volts it's doing. Where are we going to measure that, do you think? Well, you know what, it's it could well be that that wire there. 14.05. Well, if that's what it is, that's what it is. Good. So that should be all right. Now we don't have a VCO method for these sets, but nothing's been disturbed. So let's press transmit. So it's doing 3.1 watts. And you know what, it's about there on frequencies. It's 27,79138, so that's fine. But we will go through that. You've got this crystal mixer board on these sets. You've got to do the receive with a second signal generator or a marker oscillator, which we'll do in a bit. So you set the 10.24, which we will do. We don't have to do that yet because the set's so close to being spot on frequency. And we'll go through the transmitter. I'll switch the soldering iron on because we're going to have to melt those coils out, melt those cores. Are we on full power? That's a point on these sets. They have a adjustable power thing. So 3.1. It's adjustable right down to 300 milliwatts, which is very useful. So it's slightly less, it's 3 watts on the maximum on variable. There we go. I'd like to see it doing 3.5. Another good reason to use a ceramic tool when you drop it in the works. That was at peak. Yeah, that's at peak. So I'm going to have to look for our service notes. But I'm so pleased that it certainly works well with my coil. It does. So the first thing we need to do is set the 10.24, and I've had to put the radio on its side to get to an appropriate point under the phase lock loop chip. So we'll be adjusting the trimmer capacitor. There's the crystal and trimmer capacitors there for 10.24. We've got 10.2391. It's neither here nor there, is it? You know what, folks? The trimmer capacitor is faulty. I just can't get it to turn. It's kind of moves a bit, and it moves a bit the other way, but not quite where we want it. So I have to change that. Right, so 10.2389 is the highest I could get it. As we've said before. Reference crystals drop with age. Now, what that does, it's going to throw out the IF to some extent. But considering the IF is going to be 10.695 and 455 kilohertz, it shouldn't make that much of a difference. So I mean, what's the alternative? Have a crystal custom manufactured for £30 something. It's not going to affect performance at all. But you know, we'll set transmit and receive right, but it'll set the IF lopsided. So having done that, we have to now move across to this crystal mixer board here. So from the photo I've previously done, the TX one is this one here, which is capacitor 210. So with picture-in-picture on, see where that is. It is. And with that on, what we're looking for, we go to the frequency counter. And there we go. We want 27.79125. And it's as near as damn it, isn't it? So I've changed this crystal trimmer because the other one was going round in circles, or not going round in circles, but it didn't make any difference to the way the set performed. I was hoping it was going to. It didn't. So that's 65 pence you didn't need to have spent. But there you go, that's hindsight. Well, that's strange, it was the other way around last time. So the one nearest me, it's a different set, different arrangement. The one nearest to me is setting the frequency 79125. And as soon as I take the tool out, it changes, which is surprising, which is why we use ceramic tools in the first place. There we go. So now it's time to set the receive. Now, of course, we're not going to do it by ear like that. We'll be using a marker oscillator. So we're going to set the frequency counter we're going to set the receive frequency just so. And then we're going to put a second signal generator on. You've seen me do this before. Use this cheap Chinese thing, and that will be set to 10.695. Now the next problem is, how on earth do I plug this in? I have to unplug the set radio a moment, plug it into a different socket. Of course, it's a funny shaped mains adapter that only goes in certain sockets. Of course, when I've depowered the radio, it's gone back to channel 9. So we'll switch this on. And we want 10.695, which is on that channel. No, it's not. Yes, it is. So what we're listening for is just loosely coupled. is we need to, I'll turn the power up, the volume up. So we need to null that musical note. So can you hear that? Let's take it off again. The other way. Take the tool out and it's totally changed. This is as low as it will go. So let's see where that is. Slightly high, receiving at 79150. Let's see if we can get that a bit closer. Take that off. See, these are relatively modern sets, but they're still 20-something years old. So that's as on frequencies we're going to get. So now we'll put the tone back on. And we'll start with doing the receiver. I know I haven't set the TX meter yet and all that. We'll just get this, see if we can get this receiver better than the 0.85 microvolts that I did it quickly earlier on. So go over to camera 4, which seems to have moved. So now it's on frequency, the radio is slightly worse. So first thing we're going to do is put an S9 equivalent signal on. We'll look at it on the oscilloscope. Just put enough volume on for a sensible trace. And we just need to adjust the detector. Which amazingly is spot on. Right, so we'll now turn down the signal, go over to the cyanide meter, get 4 dB on there, and we'll start with the first transformer there, T1. T2, drop the signal down a bit. T3, borrow out of my radio. T4. T5, there's a bigger signal on for that. T6, see what we've got now. Yeah, it's still 1 microvolt. But everything is peaking now. Yep, 0.85 microvolts, best we're going to get. Well, you know, that's fair enough. At the end of the day, these are started life as European sets. They are an official conversion, not a dodgy conversion. So what we have to do is to sort out his coil and make sure that works. Now if we can get that coil to work, we'll put his coil in our set. If we can't get his coil to work, well, this radio goes back not working, but I have my coil back because I'm not scrapping my radio for that, obviously. So we've just got that one iffy coil. We'll just look at this IF one. It's never been fiddled with, but I will just look at that, just in case we can get something else. Yeah, might have gained a fraction there. Have a crystal filter. Right, so that does that. Let's go back to transmit and see what it's doing on, I think it was 3.5 watt on the band edges, channel 20, 4 watts. Let's just go up and down. Let's go channel 1, 3.6 watts, channel 40, 3.6 watts, so it's dead on center. It's 4.0 something at start, so that's as high as we can really go. So what do we need to do? We need to look at these presets. We're going to do a scratchy corner test on this, whether or not his coil is recovered. So it's squelch, deviation, TX meter. Let's go back to TX. Let's see what it's pressed when we press transmit. What happens? Well, we get a full set of thingies. What happens when we press the TX power thing? Yeah, right. I don't know how this is supposed to be calibrated, but it doesn't want to be going beyond its top limit, if you can understand that. It looks like it's set at full. Okay. So I've just got it so that it lights the final one. So now when we turn that down, it turns down to 6 for whatever reason, you know. Not a very light love. I don't even bother with meters, as you know myself. Right, so that's that. Deviation, let's have a look at that. While, you know, it's virtually spot on, it's a little bit low. So we'll give him a bit more of that. So that is that one there, the first one in the upper bank. That's now at full. Wasn't quite at full, it is now. Wallow. It goes 2.3, 2.4. I'd have liked a little 0.1 more, but that's how it is. So that's alright. So we want to look at the receive meter next. So put S9 on the test set. So we'll go on to internal speaker now. So we want that to read S9, but nothing is, well, is that 9 where it says it? So it's the front one. That's S9. So now if we go up, we get more. I can't see plus 30 on it. As we go down, it goes down. Good. Squelch. Can't remember how good or bad the squelch is on these. So squelch to full. So let's see where let's put the attenuator on that screen. So 1.3 microvolts, coming in at 1 microvolt for full squelch. That's useless. Squelch is the centre one of that batch. All we can do is set that to full. So really, you may want to fiddle with the RF gain to give it a better squelch range, because it is pretty atrocious, that. Turn the squelch to threshold, set that. I'll put the signal generator to standby. Switch the signal generator back on. Straight in at 0.3 microvolts. So it's a very weak squelch. About what you get on a Harvard 410T walkie-talkie. So we got, that's where we got it to. We got 4 watts. We got 2.1 to 2.4 kilohertz deviation, which is fine, and we got it to 27.79126, which is fine. TX, that's TX, RX for channel 20, 27.79139. It's slightly high. Now you could add a capacitor onto the trimmer and change that, but it's not worth it because it'll drop with age anyway, by which time that crystal will have dropped out of spec. Right, I think that is everything done. Right, so in conclusion for this, I won't put the lids on till we know whether we can recover the coil or not. So let's see if there's anybody out there. There isn't usually. 1 Roger. Switch to Roger bleep on, we might get a Roger that way. One Roger. Well, we got a bit of voice out there, didn't we? Right, so we'll work on this coil, and before I kind of sign off from this video, I'll come back on and I'll let you know whether we're able to recover the coil and whether we can actually send him this set back, or whether we're going to send it in back non-repaired with his original coil broken, put back in. So in conclusion, I've decided to leave the coil in, which is ours. I'm going to charge the customer a token £1 for that. What we've done is to put Oh, I haven't told you the whole story. I haven't told the video the whole story. The coil that's come out is actually the wrong coil that somebody's put in. So it should have a primary and a secondary. It's only got a primary, so we've spent an awful lot of time recovering that coil, and Mr. Chippy's been soldering these wires back on and all that, put it back together, and when we came to look at it, it's only got wires to 2 pins instead of to 4 pins. So it's totally wrong part. So how come that's got in? So someone somewhere knows about that. And of course it's clearly had work underneath, because you can tell by the soldering. So what we've done is to, as I said, we took a part out of our own set to get this one to work for the customer. Tell you what, let's prop it up and it might look better than there we go. So as you know, this radio receives at 0.85 of a microvolt for 12 decibel cyanide. You have to bear in mind these are a European conversion. They are an official thing. They're nothing dodgy, but they're never going to be as hot as a set which was custom made for the UK market, which these are not. And so yes, we've seen better sensitivity, but it's part of the course for these. That's fine. What I'm coming to is our sensitivity is now 7.5 microvolts, which is atrocious. We've put the coil in a similar circuit position of a similar size coil, which came out of a scrap Binatone Route 66. But of course, our set works perfectly apart from that. Oh, just what will happen is over the next period of time, I will come across, whether it's this year or in 5 years' time, I'll come across a scrap chassis, because I can buy the European version of one of these and use it as scrap, because nobody else is going to want a European version, I'm sure. And those kind of sets at radio rallies are still a couple of quid, 5 or whatever. So that'll be the ultimate outcome, and we will recover a correct part out of a scrap set in the future. So our set is back together, but is now deaf, but not deaf as in how this was when it came from the customer, which was signal generator on full pelt for it to receive anything. So he's got my part, I've got the Binatone Route 66 part. It's made my set deaf, doesn't matter, and that'll go back. It's been an awful lot of work. We've been on this since 6:30 this morning. It's now like 3:30 in the afternoon, and that's because of taking coils apart and meticulously putting the wiring back how it should be. So that's the conclusion. That's what we're doing on the air test, and he's sent, I think he sent 3 sets, so we'll be doing those subsequently. But at least he's got, and it looks immaculate, but somebody has, the phrase is, somebody has farted about with it big time and ruined it. So wonder what that coil is that went in with just a primary. Did that come out of a Fidelity 1000, which also has similar size coils? I don't know. But thanks for watching the Team Euro 3100, trying to turn it from scrap into a working radio.